All right, good afternoon, Precalculus A4. This is day one of Trig Equations. Today is a big class. We are hopefully going to be presenting to you a lot of background information. We only have a half hour to do it. It's a discussion that probably would take more than a half hour, but I'm going to try to do the best we can. Trig Equations is the last topic that we talk about in Precalculus. It is a culmination of a lot of different topics in the class. So although this year we do not have final exams, you can almost think of this as your final exam of sorts, in the sense that it's going to encompass the unit circle, it's going to involve graphs of trig functions, identities, inverses, which we talked about way back in our very first unit of pre-calc. All those topics and all the trig stuff just in general that we've talked about is kind of all going to come together for this one last blast of trig equations. All right. So as we're moving into something like trig equations, we kind of ask ourselves something like this. Something like this. Really one of the most basic forms of a trig equation. The sine of x is equal to 1/2. By the way, if you have your unit circles on you, you may want to go ahead and grab a unit circle. It'd be good to have that handy. If you have a graphing calculator, probably good to grab that. Keep it handy for today. All right, if you want to follow along. So, what if I have something like this? I have the sine of x is equal to 1/2. What we've seen stuff like that, right? When we've been solving for our angles, doing the law of sines, law of cosines, and things like that, we've seen situations come up where you're like, oh, sine of a equals some decimal, and you do sine inverse on both sides, and you get your answer from the calculator. We would solve this the exact same way. This isn't any different. What this is asking us is it's asking the sine of what is equal to 1/2. The sine of what angle, what value has a sine value of 1/2. Think of it that way. Algebraically, yes. I would say let's do the sine inverse on both sides. Okay. And I'd say that that's equal to the sine inverse of 1/2. And I would get that, again, using our handy dandy calculator. If I went ahead and typed in what is the sine inverse of 1/2, bam, it tells me it's 30 degrees, or pi over 6, right? Which is 30 degrees. Hopefully that makes sense to everybody, because the sine of 30 degrees is 1/2, of the sine of pi over 6 is 1/2, so therefore the sine inverse of 1/2 is pi over 6. But wait a minute, wait a minute. Isn't there another value on the unit circle, another angle that has a sine of 1/2? Take a look at our handy dandy unit circle here, going all the way back. The sine of 30 degrees is 1/2. That is absolutely true. But what about this one? That also has a sine value of 1/2, right? 5 pi over 6, or 150 degrees. So wouldn't we have to say that the answer is pi over 6, or how about x equals 5 pi over 6, which is 150 degrees? Okay? Because that also has a sine value of 1/2, right? Wouldn't that also be a valid answer? Or, wait a minute, what about if we went all the way back around the unit circle again? Like, what if I started at pi over 6 and I went around the unit circle and ended up right back at the same spot? Remember, we call those coterminal angles. That would be 13 pi over 6. That's 1 pi over 6 plus 2 pi, or plus 12 pi over 6, gets us all the way back to here. So do I have to say, or x equals, what about 13 pi over 6? Do the sine of 13 pi over 6, it absolutely would be 1/2. And so what is that? 30 degrees plus 360, so what, 390? Right? Or what if I did my 5 pi over 6 and I added 360 degrees, or added 12 pi over 6? What does that give me? 17 pi over 6. And 150 plus 360, what is that? 410? If my math is correct there. So what about that one? That also has a sine value of 1/2. Do you kind of see where I'm going with this? And it would just keep going forever and ever and ever. What about if you went in the negative direction? You could go the other way, and you could say, well, let's take pi over 6 and let's subtract 2 pi, get back to the same spot. That angle also has a sine value of 1/2. So what's the deal, right? Well, there are actually an infinite number of solutions just at that base form of saying the sine of what angle is 1/2. You can keep going forever and ever and ever and ever. The way that you would technically write that out with some fancy math language is you could say x equals pi over 6 plus 2 pi n. N being an integer, meaning that if you went around the circle once, you would do pi over 6 plus 2 pi. If you went around the circle twice, you would do pi over 6 plus 2 pi times 2. So plus 4 pi would go around the circle twice. Or if you went around the circle just to pi over 6 and didn't do any revolutions, you would have just pi over 6, right? And you could also say it's the other way around, where you say x is 5 pi over 6 plus 2 pi n. And the fancy math way to represent that is you'd say n is an integer. That's what that fancy little language is. It means n is an integer. Okay, that's what that little notation means. Okay, so the question, therefore, that I want to answer today is, and I don't think I was super clear about this in my A3 class, and I might just have to review it with them again, but the question that I want to answer is, why is it when I type sine inverse of 1/2 in the calculator, it tells me 30? Why? Why does it not tell me also 150 plus 2 pi n? Why does it not tell me every other angle? Why only 30 degrees? And the answer to that question has to do a lot with the graph. So that's exactly what we're going to go ahead and take a look at right now. We're going to be fancy here. We're going to be switching layouts. We're going to be probably swapping back and forth a lot. Let's go to the graph. It's my AP computer science layout, but hey, it's fine. All right, let's go to the graph, and let's take a look at what's going on here. So notice, if I have the sine of x is equal to 1/2, that solution will be true wherever these two graphs intersect each other. Here's the sine of x, here's 1/2. Whatever points those two things hit each other, that's where the sine of x is equal to 1/2. See, it's at pi over 6, it's at 5 pi over 6. And just like we said, there's an infinite number of spots where that's the case, because it would be at pi over 6, 5 pi over 6, 13 pi over 6, 17 pi over 6, 25, 29, and you go into the negatives. There's really an infinite number of answers. Why doesn't the calculator tell you an infinite number of answers? Well, it has to do with how sine inverse is defined. You may remember going all the way back to like October, September, when we talked about inverse functions. One of the very first things we talked about in pre-calc. We mentioned that for a function to have an inverse, it has to pass the horizontal line test, meaning that if I draw a horizontal line through the function, it can't hit more than once for there to be an inverse, because then two values would map back to the same thing, right? It's just like for a function, the vertical line test determines whether or not something's a function. The horizontal line test determines whether or not something has an inverse, okay? So as it is, sine fails the horizontal line test, correct? You notice that sine would clearly, this horizontal line would intersect sine multiple times. But we've used the inverse sine, so it has to have an inverse. So what's going on? Well, what we can do, and what your calculator does and what mathematicians do, is we restrict the domain of sine when talking about the inverse. So we say, well, instead of considering every single possible real number or angle, let's only look at a specific region, and then we can find the inverse of that region. Okay? You may think that that region may be to look from, from 0 to 2 pi, right? That would be probably your first guess, to say, let's look from 0 to 2 pi, just that first revolution. But if you notice, even that first revolution still fails the horizontal line test, right? Still fails, doesn't work, right? So what we kind of ask ourselves, and I'm going to go back to the unit circle here. What we ask ourselves is, looking at our unit circle, right? How far do I have to go around the circle at minimum to encapsulate all of the possible values of sine? In other words, what is the lowest value of sine that you can get on the unit circle? Well, it's -1, right? Do you see that -1 is the absolute lowest that sine can go? All of these are decimals that are greater than -1, right? What is the biggest that sine can go? Well, the largest value for sine is up here, +1, right? So in going from -1 to +1, the function can encapsulate all of the possible values for sine, right? If I look in this region right here, we get all of those possible sine values. These values over here, it's not that they're invalid, it's just that they're repetitive. We already have something that has a sine value of rad 3 over 2, right? So we don't need another thing. We already have something that has a sine value of rad 2 over 2, so we don't need another one of those things. Okay? So in order to take the inverse of sine, what we do, go back to the graph, where's my graph? There it is. Going back to the graph, I restrict sine of x from what I would like to do is I'd like to restrict it from 3 pi over 2 at the bottom of the circle to pi over 2 at the top of the circle. But it doesn't make sense to type 3 pi over 2 is less than x, which is less than pi over 2. 3 pi over 2 is greater than pi over 2. So that doesn't really make any sense. So what we have to do, instead of saying 3 pi over 2, is we say that this is negative pi over 2 to pi over 2. Okay? Remember, negative means that you're just going the opposite way around the unit circle. 3 pi over 2 is the same as negative pi over 2 because you just went pi over 2 backwards. And do you notice that this little strip, number one, encapsulates every possible sine value you could have. Every value between -1 and 1 that'll show up on your unit circle is somewhere in there. And also now passes the horizontal line test, right? So when I look at the inverse of a function, I switch x and y around, and so your inverse is going to look like that. Oh, not that. Hold on. Restricted. Negative pi over 2 to pi over 2. It's going to look like that. Okay? And so that's what the inverse function of sine looks like. It goes from negative pi over 2 to pi over 2. That's why when you type into the calculator the sine inverse of, say, 1/2, it only considers angles from negative pi over 2 in the fourth quadrant to positive pi over 2 in that first quadrant. Okay, because that's how the inverse function has to be restricted for it to pass the horizontal line test. Okay, that's why that is the case. So when I type, I'll do it again right now. Let's do the sine inverse of 1/2 again. It gives me 30 because 30 is within that range. Okay, if I did the sine inverse of, let's do -1/2, right? Now this should give me, this would give me 330 degrees or 11 pi over 6, right? If you're just looking at your plain old unit circle. But when you type it in a calculator, it gives you, if you notice, -30. It doesn't say 11 pi over 6. It doesn't say 330 degrees. It says -30. Because what your calculator does is it follows the sine inverse function defined between negative pi over 2 or -90 degrees and positive pi over 2, positive 90 degrees. So that's why your calculator will give an answer of -30. And so technically, the solution of what is the sine inverse of -1/2, just a blanket statement like that, it is -30 degrees. Okay, which is equivalent to 330 degrees, absolutely. But by the book, the answer is -30. Okie doke. Hopefully that made sense. Let's look at cosine and tangent, and then I'll give you some notes quickly. Okay, cosine's kind of the same deal. If you look here and you're saying what's the cosine inverse of 1/2, you're going to see it's the same deal where it fails the horizontal line test, fails the horizontal line test. But let's go back to our unit circle quickly again. And notice, now instead of looking from here to here, because sine looks vertically, cosine, remember, looks horizontally. So the smallest that cosine can get is this value of -1 over here. And the largest that cosine can get is this value of +1 over here. So whereas sine looks at the first quadrant and fourth quadrant of the unit circle to get all those sine values, cosine is going to look at this way, the second quadrant and the first quadrant, because that is going to encapsulate all of those possible values for cosine, going from -1 to 1. You can get them all if you just follow this top half of the circle, right? So back to the graph. to switch a lot. Where's my graph? Okay, I don't know why it only shows up when we go to full screen, but whatever. All right, so if I look there, notice you may think that you want to restrict your graph from 0 to 2 pi, still fails the horizontal line test, but I'm going to do exactly what I said. I'm going to look at the first two quadrants from 0 to pi. If you notice, that little section of cosine encapsulates every cosine value, looks very similar to the sine one, right? And passes the horizontal line test. So the inverse of that is x, switching the x and y's, because that's how we find the inverse, would look like this. Like that. Okay. And again, we have to restrict the domain so that the function passes the horizontal line test. So on your calculator, when you're doing something like that, you would say, if you typed in the cosine inverse, for example, of 1/2, right? It's going to tell you that that's 60 degrees, even though there is a perfectly good angle in the fourth quadrant that also has a cosine value of 1/2. The cosine inverse function only considers the first two quadrants. So it's only going to spit that out. It's going to be your job to then take that answer and say, oh, well, this is giving me 60 degrees. I have to also recognize that there's another one in the fourth quadrant. That's coming next class. Okay? But this is just why it works the way it works. Quickly, let's talk about tangent. We didn't really talk too much about the graph of tangent. The graph of tangent looks like this. Oh, super fun, right? It has all these asymptotes here. Just to isolate one specific section, we can isolate this section here, okay, of tangent. The reason it has these asymptotes is because tangent is undefined at a couple different spots. And tangent really, remember, refers to the slope of the line. Something that's a little more vertical, the tangent value is going to approach undefined eventually, but it's going to get larger and larger and larger and larger till it would be, approaching that undefined value. Something that's more horizontal would have a smaller and smaller tangent approaching 0. So tangent works the same as the sine. If you're talking about measuring the slope of a line, if you go from straight up and down going up, or straight up to straight down, then you can get all of those little lines in between, right? If you go from a line going straight down around to a line going straight up, well, you've just encapsulated every possible slope of the line in that range, right? So tangent is also restricted from negative pi over 2 to positive pi over 2. Because now that little strip of tangent passes your horizontal line test. Okay? So the inverse of that looks like this. If I switch the x's and y's, it looks like that. Oh, not quite like that. What did I not do? Not that. Ooh, that's kind of cool looking though. Oh, I got to restrict it. That's what I didn't do. Negative pi over 2. That's a cool looking graph though. It's a positive pi over 2. There we go. It looks like that. Okay, looks like that. And so, in short, your tangent is only as well going to consider the fourth quadrant and the first quadrant. Negative pi over 2 to 0 and 0 to pi over 2. Okay? Let me switch back off the graph and give you some quick notes on that as to what that looks like. Run through a couple examples, and then we'll be A-okay for the day. All right? So that's the plan. I know it's a lot of information. Like I sort of said at the beginning, this is definitely a discussion that would properly take, an hour or so. But, just trying to give you the abridged version. And hopefully it's making sense so far. But that answers the question as to why your calculator tells you that it's not this angle and plus 2 pi n. It's because those inverse functions are only looking at very specific sections of the whole trig function, which really goes on forever and ever and ever. All right, so let's take a look at some in particular. All right, let's make a little table here. We're going to start with y equals the sine inverse of x. Okay. Another name for the sine inverse that I'm going to start using more is y equals the arc sine of x. Okay. Sine inverse and arc sine are exactly the same thing. There is no difference between them. You see this notation come up a lot more in calculus. And the reason why is because you'll deal with a lot of problems that involve negative exponents in calculus. So to avoid confusion with this being a negative exponent versus other negative exponents, a lot of times in calculus you'll see it written as arc sine. It just is the same thing. It's the same thing as the sine inverse. There's no difference between this and this. I just want to introduce and start using this notation because that's what you'll see in calculus. It says y equals the arc sine of x. Okay. The domain of this function is from -1 to 1. Okay, because -1 is the smallest sine value that you can have, and 1 is the largest sine value that you can have. The range of this goes from -π/2 to +π/2, because sine looks for angles that are in your fourth quadrant and your first quadrant. So quadrant 1 and quadrant 4. Okay. And the graph, I'm going to try to draw it as best I can here, looks like this. Okay. It goes from -1 to +1. It goes down to -π/2, up to +π/2, and it's going to look like this. The sine of -π/2 is -1. The sine of +π/2 is 1. The sine of 0 is 0. It's going to look like this. Just like that. Okay, it's a curve, not a straight line. It's a curved line, but that's kind of what it looks like. Okay. We also have y equals the cosine inverse of x, or another term for that is again the arc cosine. Okay, same thing, no difference between them. But again, this shows up more in calculus, so this is what you're going to want to get used to. Your domain is also from -1 to 1 because -1 is the smallest possible cosine value for an angle, and 1 is the largest. Your range goes from 0 to pi in this case. Because again, we just talked about the fact that cosine looks at quadrant 1 and quadrant 2. That's enough for it to get every possible cosine value, that top arc. Okay? The graph of that looks like this. We go from -1 to 1. We go up to pi. We go down to, write that a little closer, up to pi. We go down to 0 because we're going from 0 to pi. And at pi/2, the cosine of pi/2 is 0, so we'd be right on that y-axis. And it would look like this. Okay? Ignore that little guy. And lastly, your tangent. I'd have y equals tangent inverse. Another way to represent that is, again, your arctan, arctangent. Okay? The domain of that is all real numbers. You can take the tangent of any value. It's just pretty much asking what's the slope of the line that represents that angle. That's what tangent's all about. But the range is -π/2 to pi/2. Just like sine, tangent only looks at, or arctangent only looks at quadrant 1 and quadrant 4. Arctangent only looks at those quadrants because that's how the domain has to be restricted. When I make my graph, it would look like this. Here's +π/2 on the y-axis. Here's -π/2 on the y-axis. That's as high and as low as we can go. And it's going to look like this. Approaching but not touching, those things. And the tangent of 0 is 0. So that's why it looks that way. All right. So let's take a look quickly at just a couple examples. All right. It's almost like me asking you, what is your calculator going to tell you? If I have the sine inverse of -1, what is the actual answer to that? Yes, there are an infinite amount of angles that have a sine value of -1. But there is only one answer for what the sine inverse of -1 is. I look at my unit circle. Sine inverse looks just on the right side of the unit circle. That's how it's commonly restricted. So looking just from here to here, where do I see a sine value of -1? It's here, right? The way that sine defines this is from -π/2 to +π/2. So I would say the sine inverse of -1 is -π/2. or negative 90 degrees. Okay, that is what the sine inverse of negative 1 is, as will be verified by your calculator. Okay, let's do a couple more quickly. How about the cosine inverse of, say, negative square root 3 over 2? Okay, yes, on the unit circle, there are a couple values. There are two values that have that same cosine, right here and right here. But your cosine inverse function is restricted to just look at the top half of the circle. So if we're just looking at the top half of the circle, the cosine of 5 pi over 6, that's what's going to hit that negative rad 3 over 2. So cosine inverse of negative rad 3 over 2 is 5 pi over 6. Okay. Last but not least, how about, oh, maybe we'll do a couple more. Let's see. The tangent inverse of 1. Right? Tangent looks at quadrants 1 and quadrant 4. I get my unit circle back out. I'm looking at quadrant 4. I'm looking at quadrant 1. Where do I see that the tangent value would be 1? Well, tangent is sine over cosine. So if I have the same number as sine and cosine, we take them and divide them, and that's how we get tangent. So it's going to be right here. That's going to be your pi over 4, because rad 2 over 2 divided by rad 2 over 2 is 1. Okay? So that is the actual value. The tangent inverse of 1 is pi over 4. Alrighty, we can do a couple more. We have a couple extra minutes. Really fast. If I said, what is the sine inverse of rad 3 over 2? Okay. Sine looks at quadrants 4 and 1. So I'm going to look at this half of the circle. I'm going to say, where do I see rad 3 over 2? I see it rad 3 over 2, rad 3 over 2 for sine right here. Do you see that? And so it's going to say that, oh, it's pi over 3. Okay. And let's say if we did the cosine inverse of rad 3 over 2. It's a good one. Cosine inverse of rad 3 over 2. I would look at my unit circle. Cosine looks at the top. Cosine inverse is restricted to the top half. Where do I see a rad 3 over 2? Well, right here. It would be pi over 6. Okay. One more. How about the tangent inverse of negative 1? All right. Again, oh, we did negative. Oh, no, we didn't do negative 1. Tangent inverse of negative 1. Where would I see the tangent inverse being negative 1? It would be right here, because I would do sine divided by cosine. This divided by this comes out to be negative 1, and it's within the fourth quadrant. In the first quadrant, this is where tangent inverse looks, so I would say it's 7 pi over 4. Okay? So by the books, oh, wait, we can't say it's 7 pi over 4. What are we talking about here? What are we talking about? Tangents only goes from negative pi over 2 to pi over 2. So although we like to say it's 7 pi over 4, we'd like to use that. Really, when we're talking about inverse tangent, it's going to tell us it's negative pi over 4. Right? Notice 7 pi over 4 would not be correct, because tangent is restricted. If I did the tangent inverse of, what was it, negative 1? Notice it doesn't tell us it's 7 pi over 4. It doesn't tell us it's 315 degrees. It's negative 45 degrees, because it has to be restricted to pass the horizontal line test. All right. So I know that was a ton of information that, like I said, is kind of an hour-long discussion condensed down to 30 minutes. Hopefully it at least made a little bit of sense. I certainly will post some additional notes on Google Classroom. There are also practice problems to which I will provide the answer key. Now, a lot of this was just to answer the question of, why does the calculator only tell you one answer? Why doesn't the calculator tell you all of these other possible answers? And the reason is because of how the domain and range have to be restricted so that the function is invertible and passes the horizontal line test. Okay? So if you're given a question that says the tangent inverse of negative 1, what is that? Yes, technically, there are infinitely many angles that have a tangent value of negative 1. But the only one that is defined to be the inverse is negative pi over 4, as verified by your calculator. So I think that background information is very important. As we go into equations, it's going to be important for you to understand how your domain is restricted on the equations. If your equations say that you're looking at any value of x from 0 to 2 pi, well then absolutely you have your whole unit circle to work with, and you could say it's any one of these. If it doesn't say that though, and you're just looking at strictly what the inverse is, then it's important that you understand that sine and tangent just use this half of the circle, cosine uses the top half. Poor quadrant 3 gets left out. Oh well. It's like the guy that got picked last for kickball. Yikes, that hits home pretty hard. Oh well. In any case, I hope you have a fantastic day. Hope that made sense. There's practice problems on Classroom. Please try to get through those if you have an opportunity to do so. But thank you again for your attention and focus today. I know that was a long-winded lesson with a lot of information, but it will be recorded. Please watch it back if you need to watch it back. I'll post some extra notes tomorrow. I'll grade your PAs tomorrow. I'll try to maybe, you might get a flood of posts and information from me tomorrow. That's the plan anyway. So thanks again. I hope you have a great day. And that was some good pre-calc. All right. Bye, everyone. See you Friday. Next time I'll see you.
Mr. Giorgio, just really quick.
What's up, Jacob?
So just going over one of these examples, let's do the first one. The sine inverse of -1.
Yep.
So I don't understand why you need to take the sine inverse if the sine of -1 is just pi over 2. I'm confused.
Well, the sine of what it's asking, when you're saying the sine inverse of -1, it's like what angle has a sine value of -1?
Right.
Right. And so if I look at the unit circle, what angle has a sine value of -1? It's down here. And so you say it's this, which in the context of these inverses is not represented as 3 pi over 2. It's represented as negative pi over 2.
Great. Thanks.
That's really all there is to it. It's a lot of it's kind of like a lot of background information that is useful for calculus, and we're going to use some of it, but not all of it.
Okay, sounds good.
So I know it's a lot, but I appreciate you hanging in there.
Yeah, no problem. All right, thank you.
See you later, Jacob.
Bye.
That was a lot.